Today I'm going to be solving homework problem number 4 from Module 10, Oscillations and Waves. An elastic cord is 75 centimeters long when a weight of 72 newtons hangs from it, but it is 90 centimeters long when a weight of 220 newtons hangs from it. What is the spring constant K of the elastic cord? Express your answer to two significant figures and include the appropriate units. So when I solve physics problems, I like to use something called the guess method. G is the givens in the problem, U is the unknown or what you're solving for, E is the relevant equations, the first S is for substitute, and the last is for solve. So let's start with our givens. It says the length of the cord, so I'm going to call that L1, is equal to 75 centimeters, which is the same as 75 divided by 100 gives me 0.75 meters. I'm going to change it to meters because I know that all my relevant equations are going to want meters. So L1 is 0.75 meters when force 1, when the weight is 72 newtons. Then it says that same elastic cord, so I'm going to call that L2 now, is 90 centimeters, or as I said, 0.9 meters, when a weight of 220 newtons hangs from it. So here are all my givens in the equation, or in the problem rather. So now that I have my givens, I'm going to draw a diagram to kind of show how these interact with each other. So remember, these are the same cord, right? This is the same elastic cord. So when the elastic cord has a weight of 72 newtons, it is 0.75 meters long. That's L1. This is force 1. Now, when that elastic cord has a slightly heavier weight of 220 newtons, force 2, it gets stretched further, and now it is 90 meters for length 2. So the extension of the cord, that's the kind of difference between length 2 and length 1. So the extension of the cord is L2 minus L1 for a force, which is F2 minus F1. So here are my givens, here's the diagram and how they relate to each other. Now again, the unknown is what I'm solving for, which is K. So I'm going to go and I'm going to look at my formula sheet. I see Hooke's law has everything I need. So E is for equations, F equals negative kx. I'm solving for K, so I'm going to rewrite this in terms of K. So I have K equals F over X. I'm going to omit that negative sign here because that negative sign is actually for the X and it's showing direction. It's a vector quantity, so that negative sign is indicating direction. So here, because I'm solving for K, I'm going to leave that out. K equals F over X. Now again, what's F? That's my force, and that's the extension of the cord. So F extension is going to be that difference between the force 2 and force 1. And the length, or the displacement rather, is going to be the difference between those two lengths. So it's going to be L2 minus L1. And that's going to give me K. So now I can go and I can substitute F2, 220 newtons, minus F1, 72 newtons, over 0.9 meters, 90 meters, minus 0.75 meters, and solve. K is equal to 220 minus 72, 148 newtons, over 0.90 minus 0.75, 0.15 meters. This gives me K is equal to about 987 Newton meters, which is good. I have Newton over meters, and that's my unit for K, so that's good. However, it asks for two significant figures, so my final answer is actually 990 Newton meters. And that's it.